This is my another linear algebra videos where I'll show you today how to find the characteristics polynomials of 3-3 matrix and the eigenvalues of it. Like this 3-3 matrix eigenvalues, you can find different ways, but I will show you one way that might be useful for you to understand it easily and to find it easily. For example, suppose you have been given a matrix A, which is 1, 1, 1, minus 2, minus 2, minus 1, and 0, 0, minus 1. Now, we need to find characteristic polynomials and eigenvalues of this matrix A. Now, as I said, that to find the eigenvalues, you need to find the characteristic polynomial, and there are multiple ways you can do that. The way I do, or I can just show you, is this. Like, you know that characteristic polynomial is lambda identity matrix minus A, which means you take the lambda minus 1 from each of the diagonal matrix. You have 2, minus 2. Actually, your sign will be changed, so this will be 2 and it would be 0. Then you have minus 1, lambda plus 2, 0, minus 1, 1, and then lambda plus 1. Right? Now, now we need to find the characteristics polynomial of that. So what I do, like finding the determinant. You're finding basically the determinant, or you're finding the 2 by 2 matrix. To finding the characteristic polynomial of 2 by 2 matrix is very easy, but finding eigenvalues from 3 by 3 matrix is a little bit complicated, and several ways you can do that. So what I do is this. Suppose you have this matrix, which is lambda 1, 2, and 0, and you have minus 1, lambda 2, lambda plus 2, and 0, and you have minus 1, 1, lambda plus 1, right? So take these two again, so because you need to take the 3-3 matrix. So if I multiply this way, I need to connect 3 of them. So I can take this again, lambda minus 1, 2, and 0, and the second column again, and 0. Okay, now what should I do now? Like, why I'm doing it? So that I can just connect them. Now multiply this way, okay, first, and then that way. So what you do, like, this is the 3-3 matrix, so 3 of them should be connected. So I can use a pencil here to show you what I'm trying to do. So because this is 1, it's not connected. These 3 are the first connected, so I have to multiply these 3 of them, which gives me minus 2 lambda plus 1, right? And then I have these 3, which is, if you multiply, you're getting 0, and I have these 3, if you multiply, you're getting 0. So there is nothing else I can take here. But if there is another number, then you have to just take, suppose you have plus 1 here, so you have 1 times 1 times this, so you have plus lambda minus 1 again. So you take that. But if you have 0, that means I'm not taking anything because this multiplication is 0. Now this part is done. Now what to do? You do the other way. For example, like now you need to multiply this way. So your first multiplication is like this 3, which is 0. Then this 3, which is also 0. And now you have this 3, which gives you lambda minus 1, lambda plus 2, and lambda plus 1. But the sign in between of them should be negative. So this is the second part of your product, and this is the first part of your product. Now all you need to do is just simplify it. So from the first one, I have minus 2 lambda and minus 2, and this gives me lambda 2 and lambda square minus 1 square, like a minus b and a plus b gives you a squared minus b squared. So now we have minus 2 lambda minus 2, and if you just remove the bracket, you're getting, like if you multiply, you're getting lambda cube plus 2 lambda squared minus lambda minus 2. If you simplify more, you're getting 2 lambda minus 2 minus lambda cubed minus 2 lambda squared plus lambda plus 2, and that gives you like minus lambda cubed minus 2 lambda squared and minus lambda. And if you separate the negative lambda here, you're getting lambda squared plus 2 lambda plus 1, and that gives you, so if you take the q here, so if you take separate lambda here, you're getting lambda minus lambda, you're separating, you're factoring it, and you're getting lambda squared plus 2 lambda plus 1, and now this gives you lambda plus 1 square. So this is your characteristic polynomial of this matrix A. And now if you need to find the eigenvalues, just take that equals to 0. So if you take that characteristics polynomial equals to 0, you get lambda equals to 0, or you get lambda 1 square 0, so lambda plus 1 is equals to 0, so your lambda is negative 1. So here your eigenvalues are lambda equals to 0 and minus 1. This is how you can solve for the characteristics polynomial and find the eigenvalues from a matrix A, which is 3-3 matrix. Instead of 2-2 matrix, this is 3-3 matrix, and most of the 3-3 matrix, all of the 3-3 matrix should work if you follow these. And to get the eigenvectors, you need to use these eigenvalues, and that is another video you can watch later on. But thank you very much for watching it.